And welcome to another spectacular edition of the Daily Space Weather Show. I'm your host, Dan, a.k.a. Smashomash, coming at you from the Smash News Network, least busted name in news, just bringing you the most detailed solar imagery and most comprehensive daily space weather in the known universe as we await a CME Impact coming tomorrow, August 1st. It's an exciting way to kick off the month, and we're seeing an increase in solar activity here continuing on as time goes and we get closer and closer to solar maximum. You can expect to see levels like this or higher for the coming 8 months or so, 6-8 months maybe, something like that. By the way, the Northern Hemisphere does have a small series of crown prominences. Sunspot number here over 200. Here's a quick view of the equatorial plane. And we've seen a massive plasma filament form right here under my pointer. We'll be monitoring that in the coming days. Also, a more significant crown prominence down there at the southern polar region. Huge plasma filament down there below the Earth scale. Does have the potential to create another solar polar vortex. There is one new sunspot region that's not named yet, so you can expect the sunspot number to increase yet again today. Sunspot number to increase further here, with one more new named group and also likely some more groups there soon to rise over the eastern limb. So at least one or two new sunspots, some of which could be quite large, poised to rise. The most active region was this sunspot right here by the Earth scale. It produced an M-class flare early this morning, just before we did show prep. So also there is a sunspot that's exhibited some growth in the southwestern limb. The likelihood of it producing a major solar flare will continue to rise in the coming days, not just because of its building, but because of its proximity to the solar limb. That raises the base statistical probability of it producing a large flare, including M or even X-class events. So let's take a brief look at sunspots here before we move on. Here is yesterday plus today from the SDO. So again, some growth over here. One new sunspot right here that'll get a name today. Here's colorized magnetogram for yesterday plus today also. And before we get into too much of that other stuff, we're going to talk about things like earthquakes and volcanoes. But first, if you wouldn't mind, take a moment to press like and subscribe. We've been in the process of making this a sustainable operation for the past 6 years. So help us out by visiting our links. Hit us up on social media, press the share button. Leave us a comment, tell your friends and foes about the channel, press subscribe if you're new to the content, and welcome to the Neo-Renaissance. Smashomash.com is our homepage, launched back in February of 2019. Thanks to all of our value chain partners, our subscribers, etc. If you haven't seen our Amazon shop, you can find our spaceware. Yeah, spaceware on our Amazon shop. It's amazon.com/shop/Smashomash. So check us out over there. Bunch of products there that we recommend. You can also find us over on Hemp Lucid. Link below the video to the Hemp Lucid store, as well as, again, on the homepage. So pick up your products if you are a Hemp Lucid shopper. Pick your products up through our affiliate link. We do appreciate that, as it increases the likelihood that the Smash News Network least busted name in news and these videos will continue to exist, remain publicly visible, and free for all to view. Today's featured product is a brand new one. It is one of 3 new products. And a lot of you might be amused and interested in this one, since certain things just continue on and on. Certain things look like they're incurable. What do you think? The latest featured product is, since you're sick, stay home. The graphic says, if you're sick, stay home. And maybe that's controversial for some. It comes in various different products. It's designed to perhaps create a conversation about efficacy of certain things, about certain technologies' ability to do certain things as advertised. So if you're sick, stay home. Just figured I would cover those things. Once again, press like, subscribe, share, etc. Tell your friends about the content. We would prefer for these videos to remain publicly visible, existent, and free for all to view. Let's see what's going on with Volcanoes. Fagradalsfjall complex continues to produce this spatter cone and lava flow. It is getting more and more crusted over as time goes on here, but effusive activity continues, feeding the extending lava flow, lava pond, etc. So that eruption has not ceased. We just stopped covering the live footage of it because it's getting less and less spectacular. But it is still erupting and producing some new real estate there on Iceland. So the southwestern portion of Iceland there, the Reykjanes Peninsula, continues to grow in size. Mount Mayon also erupting, producing a 9,000-foot ash plume over Luzon Island, Philippines. Karengatang, an uptick, I think, there at Karengatang on Siau Island in Indonesia, producing a 12,000-foot ash plume, flight level 120 there as Karengatang explodes. Mount Ibu also exploding, 7,000-foot ash plume over Halmahera, 6,000-foot ash plume over the Lesser Sunda Islands with Luatolo's recent eruption. Semeru producing a 14,000-foot ash plume as it explodes. It's a flight level 140 over East Java. And Rupahu on the North Island of New Zealand has exhibited a crater lake temperature with a declining trend. So cooling phase there at Rupahu. Fuego occasional emissions on Guatemala. Nevado de Ruiz producing some volcanic ash there, no indication of the ash plume size. An uptick at Sangay, 20,000-foot ash plume at Sangay in Ecuador as it explodes. It's a flight level 200. Revenador, no volcanic ash observed. Don't assume it's not erupting and go trying to pole vault the caldera. Don't pole vault the caldera. It could be unhealthful. Sabancaya, intermittent emissions and continuous emissions from Ubinas as well. So let's move right along here to earthquakes. Here is the past 90 days. Seismic activity currently low for the past 24 hours, it looks like. Looks like indeed a low number of quakes here. We'll cite quakes of a 5 or greater magnitude. It doesn't look like many. It looks like 0 quakes of a 5 or greater magnitude over the past 24 hours. So quite seismically calm indeed on planet Earth. Just keep in mind any earthquake can be a foreshock, and let's get back to space. Here comes some more splentacular imagery for you from the SDO. That's another 24-hour video featuring 2 different species of ionized iron. And we'll briefly zoom out to show the full disk view. And let's talk about some statistics. The 10.7 centimeter radial flux has actually surprisingly dipped since yesterday, now at 174 solar flux units. That was a bit of a surprise, wouldn't you say? There's the 1-year graph to put that in context. The 10.7 centimeter radial flux is this black line. Sunspot number has recently gone back over 200, so This needs to be updated. Again, radial flux now at 174 solar flux units. And let's talk about the incoming CME. So there's a great video from Tamitha Skov yesterday. If you haven't checked out Dr. Skov's YouTube channel, she did a live stream yesterday. And one of the things that she talked about was the interesting difference between the way NASA and NOAA forecast. So NASA wants to catch every CME impact, and NOAA wants to avoid false positives. So we're sort of more on the same page with NASA, and the reason NOAA wants to avoid false positives is because it's very costly to prepare for a CME impact with respect to all the spacecraft that are up there. So NOAA wants no false positives, and NASA wants to miss no CME impact because NASA has the most skin in the game. Human lives are at stake when it comes to NASA's forecast. So anyway, NOAA and NASA are currently agreeing on the forecast of the incoming CME tomorrow, expected to show up sometime early to midday here at Earth. So that's NOAA's forecast. We could see as high as a KP 6.67. That's my guess. And NASA is expecting somewhat of a direct impact there, a little bit off to the east. So we did show this yesterday, and it has been revised since then, it looks like. And by the way, Parker Solar Probe, which is kind of in between Earth and Sun here at the moment, you can see this green square, not going to help with the forecasting of the intensity of the magnetic fields, orientation of the magnetic fields, etc., because it only dumps data every once in a while. So I'm going to talk more about that here in a minute. Let's take a look at the Space Weather Enthusiast dashboard. Here is NOAA's forecast, expecting geomagnetic unrest by the time we make tomorrow's video. So geomagnetic storm conditions here expected midday and into the night. So expecting a bit of a long duration CME impact there. Again, starting early in the day tomorrow and lasting more than 24 hours. So expect about a 27-hour impact there, according to NOAA's forecast model. No arguments from me there. And again, Parker Solar Probe, while it is in between Earth and Sun here at the moment, it's not going to help with any data because, well, here's why. It only dumps its data every once in a while. And you can go get it yourself if you like from the Parker Solar Probe Science Gateway. Here is the schedule for when it does drop data. That is, the last one was on April 10th of this year, and yeah. So, but interestingly enough, if you do search for Parker Solar Probe, I searched for, what is it? Parker Solar Probe data. It says PSP releases right here. It will link you to this page, which might be useful for future videos there, the Space Physics Data Facility. I'll familiarize myself with that at a later time. And let's take a look at Earth's magnetic moment from space. So here are the past 4 hours of magnetohydrodynamic pressure. It is a geomagnetically calm situation following the subsiding of a weak coronal hole high-speed stream. So steady as she goes there. You'll see that plasma start to homogenize itself throughout the day today, making itself toward the sun's side. Here's Earth's magnetic moment from the ground for the past 4 hours. This is magnetic flux density, rather. It's showing you changes to Earth's B field in nanotesla. And this is great at forecasting the aurora, by the way. One of the many features that you can use from the Space Weather Prediction Center. Planetary K-index currently at 2. KP2 is the global geomagnetic average. And let's move to the real-time solar wind. So here is the latest from real-time solar wind data. That is the Discover spacecraft, actually. And we are seeing some variations here. So current conditions are about just under 7 protons per cubic centimeter for the solar wind density. Solar wind speed here is still slightly elevated at 476 kilometers per second, coming down from the highs around yesterday, which were a little over 500 kilometers per second. Looks like the subsiding of a coronal hole high-speed stream. And let's take a look at the GOES magnetometers next. There are your GOES magnetometers measuring the magnetic fields from their geosynchronous near equatorial orbits. Seeing kind of low highs here, and low highs and low lows actually for the past 24 hours. There's a 7-day chart if that helps you understand the GOES magnetometers. This was our last CME Impact right in here. And we are expecting this one to be a lot more interesting than that last one, as it is more directly expected to strike Earth. So next, let's talk about sector boundary crossings. So as the plasma comes out of the sun, folks, it creates a spiral known as the Parker spiral. So it's going to kind of come out like this, and that spiral has different polarities, as you can see in this imagery. And those sector boundary crossings represent a different effect of the plasma. Think of the plasma like a series of tiny subatomic or atomic scale magnets. And north versus south does have an effect on things. So the sector boundary crossings can slow down. They can cause coronal mass ejections to merge. They can cause them to push each other apart. It all depends on the magnetic fields of the plasma cloud itself, and it also depends on the polarity of the heliospheric current sheet. So these things do interact. There is magnetohydrodynamic action happening in there that is not present in a lot of the models, although there are some new models coming out pretty soon, I hear. So interestingly enough, there is an ESA meeting that we might have to comment on. Shout out to Eugene the Philosopher for bringing that to my attention. Thanks for that. And basically, the story of this is that there is some instability happening in the northeastern solar disk right now. So that is causing this sector boundary crossing to get all jumbled up, and there is a magnetic tug-of-war happening up there. So there's the latest image. Earth is kind of in the middle of a North Pole current sheet. However, that can suddenly change with basically no warning. That is the nature of magnetism in space. That's the top view ecliptic plane field plot. Here is the line of sight field plot. And again, up in this area, this is where the CME that's about to strike Earth came from in the first place. And that caused the sector boundary crossing to move. So again, as this spiral comes out of the sun, it is charged to it is polarized to one magnetic field or the other. It's either north or south pole, and sometimes it's wavy, and sometimes the fields change. Like sometimes it's like this, sometimes it's like this, and that does affect the way the coronal mass ejection will propagate through the solar system. So there's the latest image, and you can see how jumbled up fields are up here in the northeastern limb. So next we'll do coronal holes. Here's our line of sight coronal hole plot. Let me just make sure that I'm on point here. So here's our line of sight coronal hole plot. And again, you can see indecision happening up here. Indecision as to what polarity this area is. So those north and south coronal holes are sort of fighting for dominance in the northeastern limb there, and that will continue to affect the sector boundary crossing. Now there is also a huge plasma filament down in this area. Let's bring up the last image. There is a huge plasma filament right down here. That could affect things as well. So just so you are aware of that, this is just today from SDO. 211 angstroms wavelength is great at showing coronal holes. And these are North Pole orientation up here, the most well-defined ones. Although they're not that well-defined. Frankly, we've been seeing a bit of a shortage of coronal holes so far this cycle, in my opinion. You can expect an uptick coming with coronal holes as some of the most important ones have just recently left the North Polar region. as the solar cycle field reversal process occurs. So next is sunspots. 3392 is right here. That is the latest one to get named. And 3380 will have an increasing probability of producing large solar flares as it gets closer to the disk. I think I said that earlier in the video. Here are sunspots. That is yesterday plus today from SDO Continuum. So a little bit of growth in this group as it approaches the limb. Both of those things increase its propensity to produce large flares. It is beta gamma class at least, possibly beta gamma delta. An honorable mention to this sunspot group down here also. It has been producing some flaring activity, including the most recent M class flare. This group 3390, what is it, 3392? 3392 right here has grown significantly also since yesterday. Some growth down here as well. So sunspot number to rise a lot in the coming 24 hours. Those are facts. Hopefully they're not too offensive for you. And let's talk about energetic particles, since we've had a long-lasting solar energetic particle event here. There's the ghost proton flux. And that is subsiding. However, it is lasting 4 days as forecast. Two SEPs in the past 7 days there, and this one here was one of the most, I think this might have been the most significant one for solar cycle 25. There was only one that was comparable to this, if memory serves. Again, proton flux here subsiding, and you can expect the polar radio blackouts to subside possibly today. The deabsorption regions predictions depict the attenuation of the D layer of the ionosphere. This is where you can expect radio signals to not refract down to your target on Earth, but to go off into space instead. So the solar energetic particle event causes the polar radio blackouts, the solar X-ray flux causes the equatorial radio blackouts, and there is that most recent M-class flare. Right in here, some significant radio brownouts there over places like Central Asia. Oh, I'm sorry, there it is. Right over Saudi Arabia was the peak attenuation there caused by that most recent solar flare. So that event was an M2 approximately. M1.7 was the peak flux. And let's take a look at solar flares here right after we show sunspots in some additional detail. So getting back to some solar imagery here. Here is 1600 plus 1700 angstroms. Another 24-hour video from SDO. Here's the equatorial zoom. Again, multiple sunspot groups. Let me try to speak the English language. Multiple sunspot groups there exhibiting growth in the past 24 hours. So down here, that is the most active sunspot. That's the one that produced this most recent M1.7 class flare. And I could have sworn I had more close-ups. All right, maybe not. Likelihood of large solar flares rising down here. Likelihood of large solar flares certainly still available here. Also here, this group is quite complex. So multiple spots have the magnetic field shear required to produce large solar flares. Them's the facts. And let's move on to our flare wavelengths. We like to show flares in 131 and 94 angstroms especially. So let's get back to that southeastern solar limb. And right at the end of that run, you can see that M1.7 class flare. Right there. So here's the equatorial zoom. in those wavelengths, SDO 131 plus 94 angstroms. And before we talk about CMEs, we got another spectacular comet on the imagery that we're going to show you here in a minute. First, let's orient ourselves to what's going on in terms of the rest of things happening in space. Yeah, space. Beetlejuice is up there. Did you know that it's really easy to find Beetlejuice? You just find Orion's belt, and the center star makes a perpendicular line pointing right toward the red supergiant. Let us know in the comments if you think Beetlejuice is going to go supernova. My forecast is that Beetlejuice isn't going to do anything exciting. I'm not going to get into it. This is not a cosmology video. This is the daily space weather. So anyway, the sun there over the horizon over Lehigh Valley, Pennsylvania here. Saturn setting in the west. And the brightest star visible from Earth, Sirius, there just off the southeastern horizon. Let's do a cosmic ray report, as we haven't done one for a while. Cosmic rays. It is relativistic particles coming from deep space, especially. And interestingly enough, we have not seen any four-bush minima. So a four-bush minimum is when we see a sudden decline in cosmic ray flux. It is typically associated with solar energetic particle events and coronal mass ejection impacts. Also, coronal hole impacts often cause four-bush minima. We don't see any of that. We see cosmic ray flux here just down a tiny bit over the past 30 days at DOMB Antarctica's neutron monitor. DOMC agrees. Just a small downtick there over the past 30 days. You might have been expecting a large downtick because of things like four-bush minima. However, this time, not happening. So if you've got a theory as to why sometimes we see four-bush minima happening and sometimes not, despite significant solar energetic particle events, let us know in the comments. Oulu, Finland, just a shade down there over the past 30 days. Just a small downtick at Oulu. So that's interesting, wouldn't you say? Let's go much farther south to Mexico City, which is almost completely flat over the past 30 days. You might have expected a big downtick, and I certainly expected a big downtick. Well, didn't happen. No four-bush minima, despite solar energetic particle events going on for days. Athens, Greece, agrees as well. Agrees. Actually, at Greece, there's been an uptick over the past 30 days. So, and by the way, there is a large uptick in cosmic ray flux coming. Let's look at two more monitors here at Apatity and Barentsburg. So here's Apatity. Apatity is just down a tiny bit over the past 30 days, a slight downward trend there. It is indeed minor. Also Barentsburg, neutron monitor, almost flat on the past 30 days. Now, one last thing here. The more we look at the graphs, folks, the more it looks like solar cycle 25 will be a stronger solar cycle than solar cycle 23, which means we're expecting cosmic ray flux to get way down here, at least around these levels, the minimum levels reached during solar cycle 23 maximum. So don't be surprised to see these levels drop way off in the next year or so. There are some similarities to odd number solar cycles versus even number solar cycles and so on. Anyway, that's your cosmic ray report. Those are the facts. And let's move on to the solar system forecast. So that's where things are today as we bid farewell to the month of July. There's where things will be in 1 week. Again, we are expecting that CME Impact to show up tomorrow early in the day. Another slightly revised schedule for the CME Impact. Tomorrow morning may feature some great aurora in North America. So anyway, that's the situation for the solar system. And let's talk about our astronomy photo of the day. Here's apod.nasa.gov. And check it out. What's up with that? Is that just A gray boulder on the surface of Mars? Well, not at all. That's Mars's moon Phobos. A very oddly shaped moon. And it is believed to have a bunch of dust on it. So it's believed to have, let's see, perhaps a meter of loose dust. The very oddly shaped moon Phobos, believed to be an asteroid captured by Mars's orbit. Some people expecting it to crash into Mars in the next 50 million years. So yeah, Phobos is the apod.nasa.gov astronomy picture of the day. A very irregularly shaped moon with some craters and some seam-like features as well. Moving right along, 2 coronal mass ejections. So what's been going on in the past 24? Well, here's the situation. Here are yesterday's images. So 1 CME there out of the southwest, not likely earthly directed, not likely having any earthly components. It's only 39 frames for whatever reason from yesterday, and here are an additional 36 frames from today, July 31st. It's been pretty chill. And we'll just take a look at Soho-Lasco C3 as well here. There's that CME out of the southwestern limb. We'll also show Parker Solar Probe. Not Parker Solar Probe. Stereo A. Parker Solar Probe is over here. All right, yeah, Stereo A's coronagraph. Wow. Is it that early in the morning? What's up with that? And there's that coronal mass ejection. Quite a dense CME there, and interestingly enough, this one has a hollow core. See, very dense outer shell, and then a hollow core, almost like the eye of a storm. So that's a great example of a CME that if it struck Earth directly, you'd have a very strong impact, followed by a lull, followed by a weaker impact. And remember, folks, the reason that it's so hard to forecast the intensity of a geomagnetic storm associated with a CME is because we don't know what the magnetic fields are going to be like. So that makes it very difficult. Although, there are some new models likely coming out. So let's take a look at CMEs here from our custom HelioViewer movies. Here's a 24-hour video from Soho-Lasco C2, C3, and SDO 193 angstroms, and a large comet there making its way into the Soho-Lasco C2. Here's a slightly more zoomed in version. Looks like that comet might be breaking up. It's getting a lot dimmer. So it doesn't look like we have any new CMEs headed Earth's direction here. Here's 193 angstroms by itself. And I would note this massive filament. That filament is huge and perhaps deserving of a name. We've been naming them after living people. As that seems appropriate. Filaments. They are dynamic, and they almost behave as if they are alive. So that's what's going on with filaments. And before we look at filaments through the ground-based solar telescope, let's take a look at filaments from SDO 304 angstroms. That is a massive filament, and it's right in the Earth strike zone here. So if that ejects at the moment, the likelihood of it being directed directly toward Earth is much higher than if it was at the limb. So that's something to keep an eye on, wouldn't you say so? And when I say eye on, pardon the pun. By the way, if you haven't checked out the merch shop, you can get some great merch featuring the tagline, "We'll keep an eye on it." And thanks everybody who keeps an eye on our channel. That is enough space weather pun. So here's our ground-based El Teide Hydrogen Alpha telescope, and look at this filament just suddenly build. That is a massive filament. So if you want to name filaments after living people, do it over on X, the, quote, social media, and, quote, platform, formerly known as Twitter. You can find us over there. You can find us all over the internet at Smashomash, a brand that I created all the way back in 1999. And I had somewhat of a following for people in the gaming community. So since I'd already been a server admin and game message board admin and so on, going all the way back to the early to mid 2000s, we kept the name because online presence, it matters. So that's part of the reason for the branding. It's a gaming name. If you haven't checked us out over there on X, formerly known as Twitter, we did put up a tweet yesterday about the hurricane propensity in the Atlantic Ocean, which we'll cover here in a minute. Also, follow us on Instagram. If you haven't, you find diet and lifestyle posts over there, Instagram.com/Smashomash. We need more followers, so if you have an Instagram account, make sure you check it out. And here are the past couple of hours, about 2.5 hours from the GOES 18 SUVI. So that's what's going on, and it's time for bonus features. And if you're frightened, well, maybe you should get back in your bunker. Although satellites don't have to be in a bunker, they've only got minor surface charging hazards here over the eastern Pacific. So it's a pretty chill environment there for satellites at the moment. No major charging hazards at all, just some minor surface charging hazards as low-energy electrons build up on the outside of spacecraft there in the East Pacific. GOES electron flux here in a normal operating range. We can expect to see a big decline in this when the CME impact happens. As those readings become anomalous, the atmosphere puffs up with the influence of the incoming solar plasma. So you see the electron flux drop down. Those are really anomalous readings. But at the moment, GOES electron flux here in a normal operating range. There is the 1-year graph from Solon.info. Again, just right in the middle part of the range here. And NOAA's actually expecting an uptick. So we're expecting a downtick. I think this will be way down here come tomorrow's video. It all depends on when it gets refreshed, and I have no idea when it gets refreshed. Let's move on to our ionosphere maps. Feel free to pause the video on this frame if you're not familiar with things. By the way, the deabsorption region of the ionosphere, the deabsorption region predictions that we showed earlier, that is referring to this layer of the ionosphere. The DE boundary is at about 100 kilometers of altitude. Here is the F layer of the ionosphere, which is at about 300 kilometers of altitude. This is the vibrational frequency in megahertz. And expect this to drop way down. Expect low frequency anomalies starting tomorrow morning and going for about 24 plus hours. So the forecast by NOAA is about a 27-hour impact. No arguments from me there. That's the ionosphere's raw vibrational frequency for the previous day. And if that's all Greek to you, don't worry, we'll show the anomalygram. So here's anomaly in megahertz from a 30-day median. And if you're looking at this area right here and saying, wow, look at all the anomalies, that is the South Atlantic anomaly, which is now over the South American continent. That is the low spot, the weak spot in Earth's magnetosphere, the weakest spot. There is another one over here around equatorial western coastal Africa. Right around here, there's a second weak spot, not quite as weak as the South Atlantic anomaly, which is right about there. You can see all those anomaly lines converging on the same point. That's the South Atlantic anomaly. Again, expect lots of low-frequency anomalies in the coming days. There's the latest image, 11 o'clock Universal Time ionogram and 11 o'clock Universal Time anomalygram. Next is total electron content forecasts. Feel free to pause the video in this frame if you're not familiar with distances to things like the Van Allen belts, the SDO GPS satellites and the International Space Station. Here's total electron content. Anomalies here continuing south of the Indian Ocean, south of Africa, the Southern Ocean, and Antarctica. So you see all these anomalies down here. Those are areas of high likelihood of GPS errors, free electrons refracting the signal between the GPS handset and the GPS satellite. If you're expecting GPS errors in your location, try turning on Wi-Fi location accuracy. That will help things out, as Wi-Fi hotspots have a known physical IP address, which can help you with your navigation. So that's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model, the total electron content forecast. Here's the anomaly from the 10-day average over North America. And no major anomalies happening there. We're going to close out the space weather portion of this video with the latest SDO imagery. So here's the latest intensitygram, and here's the latest magnetogram. That is beta gamma delta class, folks. Its propensity to produce a large flare of M or even X class is very high. So look at all the magnetic shear right here, right in that area. So major strong magnetic fields there, very close to each other and of opposite polarity. Also, these groups, that's beta gamma delta class right there. This group here is, I think, beta gamma delta class. That is beta gamma delta class as well. So expect major activity to continue, folks. It's only an uptick from here on out until solar maximum. It's an exciting time to cover space weather. We didn't just leverage ourselves here to jump on a bandwagon, by the way, folks. I've been doing cosmology since I was 3 years old. Anyway, here is the windiest place in the world here in the Western Pacific. At least 93 mile per hour winds there. Maybe we can get an even higher reading than that. Let's see what we've got. Nearly 100 mile per hour winds around that typhoon there, which is now quite a ways east of Taiwan, south of the smaller Japanese islands. By the way, we do send out email alerts about certain types of disasters. We send disaster reports daily to our Silver and Gold Smash team members. Shout out to Smash staff, by the way, for all of her hard work. Why not give her a raise by becoming a member of the Smash team? More on that later in the video. So there's the Southern Ocean and a series of lows there surrounding Antarctica. But I suspect the lowest low in the whole world is right in there. Let's take a look at mean sea level pressure. So there's that typhoon. And I do believe that is lower pressure than those Southern Ocean low spots. Anyway, here are your friendly neighborhood wind maps. There is surface wind for the east, jet stream scenario for the east, jet stream scenario for the central world, surface winds of the central world, surface winds of the Americas, and the jet streams. There you have it. And let's talk about Atlantic hurricanes for a brief moment. Now, I've heard some rumblings from people who do not understand science. Is that too controversial to say? I suppose it's not. And what we did is we put up a 276-hour forecast here based on a GFS model because it looks like a bad time for hurricanes to form in the central Atlantic. And indeed, now keep in mind a 276-hour forecast is ridiculous. It's way too far out. Anything beyond a 72-hour forecast is just silly. There you go. There's yet another reason to follow us over on X. Yeah, X, the brilliantly rebranded, quote, social media and, quote, platform, end quote. Let us know in the comments if you think some people should be hanging from a platform as a result of the state of affairs of censorship. Yes, censorship. Let's talk about droughts next. I guess maybe that's too controversial too. Who knows? Here's our drought map based on Check Globe. By the way, there's a link to Check Globe there. Probably some more information you can look at. There's our drought map, and man, Louisiana experiencing extreme drought conditions. Also Iowa, parts of Illinois. Well, you see the map. We're showing the map because, well, there you go. That's graphics. And let's check out moisture anomaly map. There you can go. Anomalously moist there around the Mississippi Valley largely. I mean, anomalously dry, not anomalously moist, anomalously dry. Wow. All right. So there's the drought intensity map, and here's the raw soil moisture map. So continuing right along, we like to show clouds and fog over the Americas. So here's that. Clear skies over most of Brazil there. And this low right here is getting buffeted by wind shear. You can see it's having no ability to form into much of anything. It's just stagnating. Not really building at all, as there is a large anticyclone over the central Atlantic. Anyway, continuing along to our weather.gov map. If your location is lit, just head to weather.gov. There are too many counties for us to cover in this video. Maybe if we go full time with the content, we'll go over a lot more stuff. But at the moment, that's what you get. Weather.gov is where to go. I'll bet you're able to access a website since you're viewing this video on the internet. Those are your weather warnings, and there is some flooding forecasted there for some spots. Let's show the temperature anomaly forecast first, since, oh my God, Earth is burning up. Dear God, it's the hottest it's ever been since the last time. That's a 72-hour GFS temperature anomaly forecast in degrees Celsius. Most anomalously warm portion of the country is places like Oklahoma, Texas, Nebraska, Missouri. Next, our pressure and precipitation forecast based on the same GFS 72-hour model. An accurate forecast. And some quite extreme storms here about to form in the Atlantic, but they'll be off the coast of the U.S., not experienced by many except those in shipping. Yeah, shipping. Next, our total accumulated precipitation forecast. That is in inches. The GFS 72-hour total accumulated precipitation forecast. Some heavy rains expected there for Colorado, Nebraska, and South Dakota. Rain totals there coming up to around 4 inches. And lastly, the jet stream forecast. So the jet stream is going to make a big bend here, pulling some cold air down into the mid-Atlantic states. Some cold, dry air from Ontario. Going to push way down, all the way down to the Carolinas, really. That's your jet stream forecast based on the GFS 72-hour model. How you like them apples? Let us know in the comments. All right. What do we... Dag. Let me go back. If I failed to show those, I apologize. Temperature anomaly. Pressure and precipitation. Total accumulated precipitation. the jet stream. Interestingly enough, sometimes it's easier to stream a live video than it is to record one. So here's our NASA GOES lightning mapper. That's where the lightning strikes have been happening. Heavy lightning there across a lot of Florida. Here is where the lightning is happening. And just some mild activity there in the U.S. Next time you hear thunder, check out lightningmaps.org. It could save your bacon. And if you enjoy the content, don't forget to press like and subscribe. And if you want to support the content and you want additional content, become a member of the Smash team, especially at the gold or silver level. We just put up a post early this morning for gold Smash team members only. Check that out if you haven't. One of our missions is longevity. If you want to read about our mission, head to the Smasho forum. Smashomash.com/forum/mission. You can read all about our mission. Because here at the Smash News Network, least busted name in news, we are interested in facts. We are interested in increasing the quality of people's lives, advancing the science of cosmology especially, but also human technology. Smashomash.com/Smash Team. We're using technology to leverage ourselves in the right places moving forward. So thanks to our new subscribers over on YouTube. If you haven't subscribed yet, do yourself a favor and do so. Did you know that our thumbnails have more information that is valid to reality than entire channels? Yeah, our thumbnails. Our thumbnails have more info than entire channels' repertoire of content, because there are some channels on YouTube who are paid a lot of money to commit science fraud. Science fraud. You can also find a link to the Redbubble shop and so on. So become a member of the Smash team, press like, subscribe, share, etc. We'll wait while you do so. Have you pressed those buttons yet? Well, thanks to everybody who has. It's only the world's most comprehensive daily space weather and detailed solar imagery you'll find in the known universe. Space weather, not scary. No, the sun is not going to kill you. Yes, geomagnetic storms cause increased radiation exposure for polar flights and astronauts. Here's our U.S. Doppler radar map. We're going to close out this thing with the lower 48 scenario. So there is a lower 48 Doppler looking at vertical motion in the air column. Some storms there moving south-southeast. As you can see there on the clouds and fog map, the shortwave radiation satellite. And there is the water vapor map. You can see the jet stream making that bend as time goes on here. Cold air about to make it way down to the Carolinas. And some heavy rains happening up here in the central U.S. Here's where we'll close this thing out with a recap. U.S. Doppler radar, clouds and fog, and water vapor. And that is that. We'll see you tomorrow, or maybe even later today, depending on what happens. Once again, thanks for tuning into the Smash News Network, least busted name in news. We're frankly surprised that you've found the content, and if you're frightened of space weather, well, just go hide in your bunker. Anyway, see you next time. And until then, may that solar wind be at your back.